Hello students, welcome you back to GK's maths classes. Today we are going to discuss a topic called determinant from class 12th. We have already finished the matrix, all the relevant questions pertaining to matrix. So this is a video pertaining to doing determinants. Okay. Today what we are going to do is we are going to talk about what is a determinant is. We'll also try to understand how to expand a determinant, what is a minor, what is a cofactor, how do I find adjoint of a matrix, and how do I find inverse of a matrix. And we'll also solve some problems related to that. Okay, this is the thing, and we will also be continuing determinant in the next video, where I will be talking about the big questions like how to solve system of linear equations and all that. Okay, so I would request you to subscribe to my channel and also to press the bell icon to get notifications of all videos that we post. Okay, shall we continue now? So determinant. So what is the definition of a determinant? Now, for example, for instance, you take a set of all square matrix. I don't take any matrix, I just take set of all square matrix. So you know what a square matrix is. You take all collections of square matrix. It can be a 2 by 2, 3 by 3, 4 by 4, 5 by 5, n by n matrix. Now, for each and every matrix, suppose if I take A as a matrix, for every matrix, I will associate a unique real number. This is set of all real numbers. For every square matrix, I associate a real number. That real number is nothing but the determinant of the matrix A. Suppose if I associate, say for example, K, a real number K, to this matrix A, then I will say determinant of A is K. The symbol is two parallel lines. You don't read it as modulus of A, you read it as determinant of A. Determinant of A is K. And the same matrix will not have some other real number. It is always unique. For every square matrix, there will be a unique real number. Okay. So this is more of a function. For example, if I say determinant is a function from what? From set of all square matrix to real numbers. It's a real valued function. You know what a function is? So determinant is a real valued function where the domain is set of all square matrix and your range is all real numbers. Okay. Now you can, so this is a symbol that I use. A determinant is a function. It is a function that takes square matrix to real numbers. What is the difference between matrix and determinant? Matrix is a representation. When a data is given, you are representing a data in rows and columns. What is a determinant? Determinant is not a representation. It's a value of the representation. You're giving a number to it. What is the number? The number that you associate to a square matrix. The number that you associate to a square matrix is called determinant. So determinant is a number, whereas matrix is a representation. Okay. So with that, we will try to find out how to expand a determinant. Now I just want you for the time being to remember that a 3 by 3 determinant should always have plus, minus, plus, minus, plus, minus, plus, minus, plus. I call them as cofactor, and then we're going to talk about minus and all that later. But for the time being, just remember it's plus, minus, plus, minus, plus, minus, plus, minus, plus. And for a 2 by 2, it will be always plus, minus, minus, and plus. We are going to define cofactors and all that. We will come to that in the next slide. But right now, just without even knowing the cofactor and minor, let us see how to expand the determinant. Suppose if I have a matrix A whose determinant I want to find. So let me take a random determinant. Say for example minus 2, 3, minus 5, 6, 1, minus 1, 2, minus 1, 3. Okay, I just taken some values. Maybe I'll take this positive and I'll make this as negative. Just any determinant. Now how do I expand? There are totally 6 ways to expand the determinant. There are totally 6 ways. You can expand the determinant in 6 ways. Now what are the 6 ways? You can expand with respect to 3 rows, or you can expand with respect to 3 columns. You can expand with respect to 3 rows, or you can expand with respect to 3 columns. Whether you expand with respect to row 1 or row 2 or row 3, column 1, column 2, column 3, it doesn't matter. The value of the determinant will remain the same. Okay. Expansion of determinant will have same value irrespective of what? Irrespective of whether, irrespective of expanding with respect to any row or column. So that is full freedom. You can expand the determinant with respect to row 1, you can expand the determinant with respect to row 2, you can expand the determinant with respect to row 3 or column 1 or column 2 or column 3 conveniently. You don't have to worry about it because the value of the determinant is going to be the same. Now what I am going to do now is I am going to expand this determinant with respect to row 1. I am going to expand with respect to row 1. Expansion with respect to row 1. How do I expand this determinant with respect to row 1? This row 1 is this, correct? Now I always remember this. What is the sign? It's plus. It has nothing to do with the sign of the numbers here. They are independent. So the sign is plus. So we generally don't write plus. It's understood plus. If you don't write anything, the number starts with plus. So it's plus. What is the number? The number is 2. We are expanding with respect to row 1. So the first number is 2. Now what do? Omit this row, and what do? Omit this column. Omit this row and omit this column. So you have a 2 by 2 determinant. Now how do I expand this? Very simple. Always first you multiply top to bottom. This one 1 into 3. So what is 1 into 3? 3. Always this first, 1 into 3, and when you go against gravity, you always put a minus sign. Okay, minus 1 is 1. I hope you understand that. I omit this row, I omit this column. 3 minus of product of these two. Okay, now I go to the next element. What is the next element? It's minus 3. But what is the sign here? The sign is minus. So first you put the minus, first you put that minus sign, and what's the number? The number is minus 3. You see, because there is minus 3, it's not that you put minus 3 and walk away. No, this sign have to be put. That is the cofactor. Okay, the minus sign into minus 3. Now what do? Omit this row and omit this column. See now, I have omitted row 1 and I have omitted column 2. Okay, and I will remove this. This is not required now. So what I should multiply by? Okay, I think it was what was the number? It was minus 1. Okay. Now how do I expand that? 6 into 3 is 18. 6 into 3 is 18. When you go up, you have to put a minus sign. 2 into minus 1. 2 into minus 1 is minus 2. Then you go to the next number. What is the next number? Next number is minus 5. But what is the sign? Sign is plus. Plus. What's the number? Minus 5. Now just move this. So what happens here? Leave this row, leave that column. Multiply. 6 into minus 1, minus 6. When you move up, you have to put a minus sign. 2 into minus 1, 2 into 1 is 2. So what's the value? 2 into 3 minus 1 is 2. Plus 3 into minus is plus 3. 18 minus of minus 2 is 20. Minus 5 into minus 8. Correct? Now this is 4 plus 60 plus 40. So what is the answer? 100, 104. This is the value of this determinant. That means if I have a matrix, if I call this matrix as A, for this matrix you have a unique real number, say it is 104. I hope you understand how to expand the determinant. We'll be doing more problems, so then I think it should be clear. So always remember, if you're choosing first row, don't forget plus, minus, plus. If you're expanding with respect to row 2, you have to start with minus, plus, minus. If you're starting with row 3, it is plus, minus, plus. But when you're expanding with respect to row 1, omit that row and omit the corresponding column and choose the other matrix. Okay. I hope you understood how to expand a 3 by 3 determinant. I will also explain to you how to expand a 2 by 2 determinant. Let us take a determinant 2, minus 1, minus 5 and 6. Now how do I expand? Very, very simple. Multiply this. 2 into minus 1, minus 2. When you move up, you put a minus sign. What is minus 5 into 6? Minus 30. So what is the answer? Minus 2 plus 30. So it is equal to 28. So for this matrix 2, 6, minus 5, minus 1, you have a real number. What is the real number? 28. This is a matrix. It's a representation. Whereas 28 is the value of this matrix. Okay. And so determinant is a function. That's what I was talking about here. A determinant is a function which takes a square matrix to real numbers. So if you notice this, here it is a square matrix. This square matrix is associated with a real number. This is a square matrix, it is associated with a real number. And determinant can be found only for square matrix. It cannot be found for a rectangular matrix. I hope you have understood. So the first part is definition of a determinant. Determinant is a function which takes square matrix to real numbers, and determinant is a number. Don't forget, determinant is a number, it's a real number. Matrix is a representation. First one. Second is you also learned how to expand the matrix with respect to first row or second row or third. We can expand with respect to any row or column. There are totally 6 ways of expanding the determinant. And I taught you how to expand the 3 by 3 determinant, and I also explained to you how to expand a 2 by 2 determinant. I hope these two are clear. Now what we will do, we will continue further. Now I want to talk about the most important part where a 6-mark question or a 5-mark question comes generally, is how do I find inverse of a matrix, how do I find cofactor of a matrix, what is a minor of a matrix, and what is adjoint of a matrix. To some extent we have already done it there. Okay, and let us see how to go about it. Now cofactor, see, this is a matrix, and it has it is represented, we have already discussed it before. This is a matrix which is written in the form Aij, where it's a square matrix, you see. It's a square matrix. So small letters stand for alphabet, stands for elements. Okay. Now cofactor of A, generally denoted as Aij. Cofactor is denoted as capital Aij. That's a notation used in the NCERT book. Some books use Cij, but we follow what is the NCERT saying, is defined as minus 1 to the power of I plus j into minor of ij. Okay. So what is this minor, and what is Mij called? Mij is called minor of matrix A. Okay. So we'll find out what is a minor and what is a cofactor. So this is how it is defined. A cofactor of A is defined as minus 1 to the power of I plus j into m of ij. M of ij is called minor of matrix A. So minor is Mij notation and cofactor is this, and this is a formula that connects minor and cofactor. Now how do I calculate it? I'll come back to this later. Now inverse. The inverse of a matrix is defined as 1 by determinant of A into adjoint of A. This is called adjoint of A. So what is adjoint of A then? Adjoint of A is defined as cofactor of A whole transpose. Adjoint of A is defined as cofactor of A transpose. So A inverse is 1 by determinant of A into adjoint of A. What is adjoint of A? Cofactor of A transpose. What is cofactor of A? Cofactor of A is minus 1 to the power of I plus j, Mij. What is Mij? Mij is the minor. And if you want A inverse to exist, if you want the inverse to exist, definitely determinant value should not be 0. Or in mathematical language, it's called non-singular matrix. This is something similar to division of matrix. Okay, you can just imagine this is like a division. You don't have A by B, you call it A B inverse. Okay, so A inverse is something similar to inverse of a matrix. So this is one of the results that you should know. And the second result is also very important for me, that if I take A, B and multiply the whole inverse, it is nothing but B inverse into A inverse. It is just like what it did in transpose. AB transpose is B transpose into A transpose. Here AB inverse is B inverse into A inverse. And the third result is also very simple. Okay, A inverse of inverse is A. Just like you say A transpose of transpose is A itself. Okay, so right now let us not go too much into detail of all this, because it will be very confusing, all new terminologies. So we'll go one at a time. So first of all, you have a matrix and I'm going to find cofactor, I'm going to find minor, I'm going to find adjoint, and I'm going to find inverse. Okay, so first let's finish problems based on these things before we go into little deeper things. Okay, let's go to the next problem. Now look at this question. Through this problem, I am going to explain all these ideas. Okay, let's go one by one. I am given a matrix A, which is a square matrix, and I want to find A inverse for this. Okay, and I want you to remember that you should not forget plus minus plus, minus plus minus, plus minus plus. We'll go as slowly as possible. So the most important thing is to check whether inverse exists. If you want inverse to exist, determinant value should be not 0. So that is my first task. Always find determinant of A. So what is determinant of A? Determinant of A is determinant of 2, 1, 3, 4, minus 1, 0, minus 7, 2, 1. Okay. Now I want to expand with respect to row 1 or row 2 or row 3, your choice. I always feel comfortable with row 1. I am going to expand with respect to row 1. Now how do I expand with respect to row 1? Put a box here, row 1, sorry, column 1, and this is row 1. I am going to expand with respect to the row. Now how do I do it? So first element is 2. Positive sign, so it's plus 2. I just take 2. Leave this row, leave this column, multiply, minus 1, minus of 2 into 0 is 0. So good, my job is done. Go to the next element. What's the next element? The next element is 1. The next element is 1. Right? Now what is the sign? Sign is minus. So it is minus 1 into, multiply, 4 into 1 is 4. Minus 7 into 0 is 0. When you go upwards, you have to put a minus sign. Don't forget that. Now go to the next one. What is the next element? 3, and what's the sign? Sign is plus. So it's plus 3 into, what do you get? 8. 4 2s are 8. 4 2s are 8. Minus, always put a minus sign when you go upwards. Minus 7 into minus 1 is 7. So I have expanded the determinant. Now what is this value? 2 into minus 1, minus 1 into 4, plus 3 into 1. So what is the value? Minus 2, minus 4, plus 3. This is minus 3, which is definitely not 0. Therefore, A inverse exists. Important, isn't it? A inverse exists. So that finishes determinant. So I have already explained to you how to find the determinant. Using the same idea, I have found determinant of this matrix. And you understood? For every square matrix, you have a unique real number. Here, the unique real number is -3. Now I want to find inverse. To find A inverse, what is the formula to find A inverse? The formula to find A inverse is 1 by determinant of A into adjoint of A. So I already finished finding determinant of A. Now my job is to find the adjoint of A. Now how do I find adjoint of A? For that I have to find cofactor. Now what is cofactor? See this. A11. A11 means cofactor of first row, first column element. First row, first column element. Okay. Now generally you can if I have to use the formula effectively, it is -1 to the power of I plus j. Here I plus j is 1 plus 1, that is 2. Okay. 1 plus 1 is 2. And then I write the minor. Correct? This is the actual way of doing it. -1 square is what? Plus. That is what is here. Okay. So when I say plus, it means I'm talking about this. So -1 whole square. -1 whole square. How do I get whole square? A11 is defined as Aij is defined as -1 to the power of I plus j into Mij. So here I is 1 and j is 1, so I get whole square. That is why you are getting plus. Okay. Now what is M11? Say this. First row, first column element, right? Leave that. Omit that first row, first column. This, if I have to write effectively, it will be like A11 equal to -1 whole square, determinant, it's -1, 0, 2 and 1. Can you see it? -1, 0, 2 and 1. If ignoring that sign, it becomes minor, just the minor. The minor is, you leave the row, leave that column. Whatever determinant you get, that is called minor. Okay. So this is nothing but -1 whole square is 1. No. And how do you expand this? It is -1 into 1 is -1. 2 into 0 is 0. So A11 is -1. A11 is -1. Okay. Now I'll do one more with the formula, then afterwards we will not use this. A12 is -1 to the power of 1 plus 2 into M12. What is -1 power 3? -1 power 3 is minus. Correct? That is why you have minus here. Clear? Now what is M12? Let's go back to this. Omit this row, omit this column. When you omit the row and omit that column, what determinant you get? 4, then 0, -7 and 1. So what's the value? Minus is outside. 4 into 1 is 4. -7 into 0 is 0. So the answer is -4. So A12 is -4. Now I want to go for A13. If I keep writing like this, time will be wasted even in the exam. So to make you understand, I use this formula. Otherwise, use the logic. What is the sign here? Put the sign as plus. Don't forget that sign. If you forget that sign, it will become minor. If you take care of the sign, it becomes cofactor. So it's plus. Watch this. What do you get? Leave that row, leave that column. This is the determinant that you should look for. What is the value? 4 2s are 8. 4 2s are 8. Minus sign when you are moving up. -7 into -1 is 7. So what is the value? 1. So I have finished A11, A12, A13. I have exhausted the first row. Now I want to go to the second row. I want to go to second row. So that is A21. Now A21, what is the sign? The sign is minus. Put the minus sign first. Then second row, first column. Can you see the determinant? What is the determinant? 1 into 1. Can you see this? 1 into 1 is 1. Minus is going up. 2 into 3 is minus 6. So what is the value? The value is 5. Clear? Now I want to go for A22. What is A22? A22, what is the sign? The sign is plus. Put the plus sign first. Now what do? Shift this. Second row, second column. Now what is left out here without the cross? You get 2 minus of, what is minus 7 into 3? Minus 21. So what is the answer? 23. Okay. Now we'll go for A23. What is A23? The sign is minus. Sign is minus. Open. Now shift this to the next. What do you get? 4. It's 4 minus of, what is minus 7 into 1? Minus 7. So what do you get? This is 11, so it's minus 11. So I have exhausted my first row, I have exhausted my second row. Now I have to go to the third row. Okay, I'll use some other color just to make a difference, that's all. Now what is A31? A31 will be this element, right? And what is the sign? The sign is plus. The sign is plus. Open the bracket. Shift this down, third row, first column. What do you get? 1 into 0 is 0. 1 into 0 is 0. Minus. What is minus 1 into 3? Minus 3. So the value is 3. Now you go for A32. What is A32? What is the sign? Minus. Shift this. What do you get? 2 into 0 is 0. Minus 4 into 3 is 12. So the value is 12. Now finally you come to A33. And what is A33? A33 should be second row, third row, third column. So what do you get here? This will be minus 2. When you move up, it becomes minus 4. Therefore, this is minus 6. Now that you're finished, the blue stands for row 1, red stands for row 2, green stands for row 3. So let's first write the cofactor of A. Cofactor of A will be, what is cofactor of A? Write all the elements. Minus 1, then minus 4, 1, and then 5, 23, minus 11, and 3, 12, and minus 6. I hope this is clear. Now I want to find adjoint of A. Now what is adjoint of A? I have told you adjoint of A is nothing but, adjoint of A is cofactor of A transpose, correct? This is my cofactor. Take the transpose. So what do you get? Minus 1, 5, 3, minus 4, 23, 12, 1, minus 11, minus 6. Now I want to find A inverse. What is A inverse? A inverse is 1 by determinant of A. What is my determinant of A? 1 by minus 3. So 1 minus 1 by 3 into, what is the adjoint of A? Minus 1, 5, 3, minus 4, 23, 12, 1, minus 11, minus 6. Very lengthy sum, very, very important type. If you miss this, you will lose 5 marks and it will cost you very badly. So you have to be, it is not tough, but you need to concentrate. Okay. Now, here I will also talk to you about what is minor of A is. Minor of A is very simple. Remember, if you don't consider this minus, plus, minus, plus, minus, plus, minus, whatever number you get, that is the answer. And basically only these elements will change. See, here only you change the sign, right? So rest of the things will be same. So it's minus 1. If it is minus 4, you put plus 4. 1, minus 5, 23, 11, 3, minus 12, minus 6. That's all. You see, only at A12, you see, A12, A21, A23, and A32, you have changed minus. You introduced a minus. So if you don't consider the minus, if everything is taken as plus, it's called minor. I hope you understand. So this is cofactor. So here, as I told you, we have understood how to find a cofactor. You have understood to find a minor. You have understood to find an adjoint. Now you have also understood how to find inverse. And you know inverse exists only when determinant value is not 0. Okay. Now I want to do one more question in 2 by 2 matrix. Okay. How do I find inverse of? Suppose if I have a matrix A equal to 3, minus 1, 7, and say 3, some minus 2, some example I take. Okay, how to find inverse of this matrix? Now to find inverse of this matrix, first what I will do, I will find determinant value. So what is determinant value? 3, minus 1, 7, minus 2. Now how do I find the determinant value? This is minus 6. Okay, minus 6, minus of 7. Correct? Minus 6, minus of, when you go up you put a minus sign. 7 into minus 1 is minus 7. So what is this? Minus 6 plus 7. So the determinant value is 1, which is not equal to 0. I hope this is clear. Now how do I find adjoint? A 1, 1. Okay, and you remember you have plus, minus, minus, plus. So what is the sign? The sign is plus. The sign is plus. Leave this row, leave this column. Leave this row and leave this column. So what is the element? You have minus 2. So the answer is minus 2. What is A12? For A12, just move this. What do you get? And what is the sign? The sign is minus. So don't forget to put that minus first. Now it is 7. Now you write A21. For A21, what is the sign? The sign is minus. Now just move this. What's the number? Minus 1. So it is 1. Now I want to find A22. What is the sign? The sign is plus. And bring this to second column. The number is 3. So what is cofactor of A? Cofactor of A is minus 2, minus 7, 1 and 3. Simple, isn't it? Now how do you find adjoint of A? Adjoint of A is cofactor of A transpose. So what do? Minus 2, 1, minus 7 and 3. So what is A inverse? 1 by determinant of A. So it is 1. 1 by determinant of A is 1 by determinant of A into minus 2, 1, minus 7 and 3. So A inverse is equal to minus 2, 1, minus 7 and 3. I hope this is absolutely clear to you. Now how do you find minor of this matrix? Minor, the minor of this matrix, or you can say minor of A is, how do you find minor? I told you that ignore that minus sign. So this is minus 2, there is no change here. Whereas you have introduced a minus sign here. So it should be 7. Here it should be minus 1 and it is 3. I hope this is absolutely clear to you. And we have learned all this. We will do more problems in the next video because I think it becomes very lengthy. So I hope you have understood how to find inverse of a 2 by 2 matrix and you have found inverse of a 3 by 3 matrix. And we'll do more problems in inverse in the subsequent classes. I hope this video was very useful to you. See you in the next video. Do subscribe to my channel and also press the bell icon for further notification. Thank you very much. Have a lovely day. Bye.